Let's start the last chapter of this semester. Let's check the first section, exponents. The first objective is how to evaluate the exponential expressions. So let's check some examples. Because we already know the exponential expression just repeated the multiplication with the same factor, right? So let's check some example. Let's see if we have 2 to the third. So how can we erase it? So we know the factor, the same factor here is just the 2. And we have 3, 2. So we will write it like 2 times 2 times 2, and we only need to do the multiplication. For example, we have 3 to the first. Now we still know the number here, the base here is just the factor. So we have 3 as the factor. And how many 3 do we have? We just have 1. So 3 to the first, we just equal to 3. Let's check this one. So before we start this part, we should know what is the base here. It's just the 4 or the negative 4. Then we think we put the parenthesis here, which means the whole part in the parentheses is our base. So negative 4 will be our factor. So negative 4 times negative 4. So make sure you understand. The whole part in your parentheses is the factor. So you should, every time you should use negative 4 times negative 4 for this question. So we know negative, we will get positive 16. Let's check another one. Very similar, looks similar to the previous one. But this time, what is our base? It's negative 4 or 4. Because you know here we do not have any parentheses. So we will just treat 4 as our base. If 4 is the base, so first we should keep the negative sign. We put the negative sign first. After that, we know it's 4 is the base. Then times 4 because we have 2, 4. After that, you should keep the negative sign. Then do the multiplication 4 times 4. So this time we will get a negative 16. You compare these two questions, make sure you understand there is a big difference. Okay? So if you have the parentheses, then the whole part in your parentheses is just the base. But if you do not have it, it's just the single value here. So you should keep the negative sign here. Of course, we could have the example just like this one. How can we evaluate this part? What is the base we need to figure out? So for this expression, only this part is the exponential expression, right? So this is the part with exponent. So we will say the base here is just the 3. The base is not 4 times 3. It's just the 3. So we should keep 4 like this. But for the exponential part, we should write 3 as our factor, and we have 2 3s. So we will do like this. Do the multiplication. Okay, that's the first part, how to evaluate. So when you have the multiplication form like that, make sure you understand. Here, we do not have the parentheses, so only 3 is the base. For example, if we have the parentheses, now this time we will get 4 times 3 as our base. Then we could solve it first to get 12 to the third. Then we will get this value, right? So these two are totally different. Okay, we can see another kind of example. So if we have 2x to the third, but we know when x is 5. So we still need to know how to evaluate this kind of question. So this time we have an expression with the x, but we already know the x value. So I will say I will put the x value in the parentheses, then copy the remaining part. So just like I said, this time only 5 is our base, right? Because 5 is in our parentheses. So I would say 5 is the base, 5 is the factor. The remaining part, we only need to do the multiplication. Okay, so let's check another one. So if this time we have this expression, when x is -3. So this time, we still need to use -3 to replace our x. But make sure when you use a value to replace x here, you should put a parenthesis. You should put a parenthesis. So you should write like this way. Put your value, x value, in a parenthesis, then copy the remaining part. If you put a parenthesis, then you will understand that the whole part in the parenthesis is the base. So this is -3 is the factor. So we should write -3 times -3, okay? The -3 is the repeated part. So the remaining part we will get 1. Because here we will get 9, right? 9 over 9 will get 1. So that's the first objective. Let's move on to the second one. We will using the product rule. We will talk about the product rule. Let's see. If we know we have the rule like 2 exponential part do the multiplication if the base is the same. Make sure you know the requirement is a is equal to a. So they are just the same base, okay? So I will keep the same base. If it's the multiplication, then I should add up their exponents. I should add up their exponent. So for the first term, the exponent is m, and the second term is n. I should do the addition for the exponents. Again, I will keep the common base and add up their exponents. So let's see the example. 3 to the 5, 3 times 3. So first we realize this is the multiplication, right? This is multiplication. Then we check if these two terms have the same base, realize they are same. So I will just keep the same base. Next step, we should do the addition for the exponent. So 5 plus 7. So we will write like this. 3 to the 12. Again, keep the common base, add up their exponents. Okay, but some students do like this way. 3 times 3, I will get 9. Then I would add up their exponents. Now I will get this answer. Is that correct? I would say, no, this is wrong. This is wrong because I only need to keep the common base. So if it's 3, just keep the 3. Not do the multiplication for the base. Okay? The fact is still 3. The base is still 3. Let's check another example. So this time we have this expression. So we know we are doing the multiplication, right? We are doing the multiplication. Now we check, do they have the same base? We will say yes, and the base is 4, so we just write down 4. Next step, we're gonna find the sum of the exponents. So 2 plus 5, we will have 7. So 4 to the 7th is just the answer. Okay, just the answer. Okay, let's check one more, or maybe 2 more. Okay, this time, sorry, this is the multiplication. So first it's multiplication. Now we check if they have the same base. Yeah, they have the same base. X is the base, so I write down the common base here is X. Next step, we only need to find the sum of the exponents. So this is our final answer, X to the 7th. How about this one? We still do the same thing. So check, it's the multiplication, okay? Now, next, check if they have the same base. We will say, yes, the same base is y. Then we copy down the y. But next step, we should find the sum of the exponents. So we know the exponent of y to the 3rd is just the 3. But how about the y? Do you understand? The exponent here is not 0. It should be 1. It should be 1. We just didn't put the 1 there, but it's still the 1. So after you know that, you should find the sum of 3 plus 1. Don't think that 1 is the 0. That 1 is the 1. Okay? So you will get y to the 4th, of course. Let's check one more. This time, so we know we are doing the multiplication. First, this is the multiplication. After that, we check, do they have the common base? And we realize they have the common base. So the base here is -5. So we should put negative here. But after you write down the negative, don't forget put the parenthesis there. Don't forget to put the parenthesis there. After that, you only need to find the sum. If you forget the parenthesis, you will get totally wrong, okay? So don't forget, you should write down the parenthesis. Use the parenthesis. Again, don't forget that one. Okay, so that's the second objective. The third part, we will use the power rule. Power rule. What is the power rule? We will say if mn are both real number, then we will have this rule. We still write down the base here, but we will get the product of m times n. We will get this. This is called the power rule. Okay? how do we understand this one? We can use the example to help you understand. For example, we have 3 to the third, then to the, if we just use the multiplication rule, no, we just use the basic property of the exponent, we will understand. The base is the whole part in the parenthesis. Then the base here is 5 to the third, right? And we are doing the multiplication part. Each time we repeat 5 to the third. And we will have total 6 terms of 5 to the third. Now we're gonna use the the multiplication rule. We are doing the multiplication, right? And each term has the same base, so we just write down the same base. But this time we will find we need to 3 plus 3 plus 3. So total we will have 6 3. So that's why we could use 3 times 6 or 6 times 3. That's the same thing. We will get 5 to the 18. So if you understand this one, now you should know that is actually our power rule. So you should memorize. We have this form. You have the exponent in the parenthesis, and you also have the exponent outside the parenthesis. Just write down the base, then find the product of 2 exponents. Okay, let's try to see another example. So this time we have, so remember, in the parenthesis, we have the exponent. Outside the parenthesis, we have another one. But first step, we're going to keep the base. Keep the base. So this time, we have x is the new base. Now, we should find the product of 2 exponents. Now, it is x to the 35. Okay, so this is called the power rule. Again, inside the parenthesis, we have the exponent. Outside, we have another. Then we treat the base inside the parenthesis. So we treat the base x. Now we do the, write down the x. After that, we find the product. Now, next one, we will talk about the objective. So this time, we still use the power rule, but we will do the products or quotients. So we should put them together this time. For example, we have x, y, x times y, then to the 3 to the third. How can we evaluate this one? So now we know the base here is the part in the parenthesis. It will be x times y, right? X times y. Now we should repeat it, our base, 3 times. Total, we will have 3 x times y. So we did like that. Then we combine the like term. X times x times x times y times y times y. We combine the like term. After that, we know we could write x times x times x to this form, x to the third. Then times y times y times y to be y the third. So from here, we know we have a new rule called the power of a product rule. So we have something in the some product in the parenthesis. Then outside, we will have the exponent. We will write it like a to the n times b to the n. Okay, we will have this rule. This is called the power of the product rule because in the parenthesis, the base now is a product. So let's check another example. For example, we have this one. So now we know there is a product 2 times a in the parenthesis. So this is our new base. So I will say it is the one of the number to the third times another one to the third. Of course, we can evaluate this 2 to the third to be 8. So our answer will be 8a to the third. Let's check another one. This time, now we realize in the parenthesis we have lots of terms. The first one, we will think it's the -5. Another one will be the x squared. The third one, we have y to the third, and the last one is z to the 1, right? It's not 0. Again, it's not 0. It's z to the 1. Now we only need to list each term. First term, we should put the parenthesis here. It's the -5 term, okay? So we should put the -5 into the parenthesis, then to the second. Then we do the second term, x squared. We still to the second. Now y3 to the second. The last one, z1 to times. After that, we only need to use the power rule, right? So the first one we could evaluate. Again, the whole part in the parenthesis is our base. So you should write it as -5 times -5. Okay? So after that, you will get a positive value. So for this one, we just write, because inside we have an exponent, outside we have another. So we only need to find the product, 2 times 2. The same term for the y. Inside we have 3, outside we have 2. We need to find the product. The last one, inside we have 1, outside we have 2, so we have 2. After that, rewrite your answer into this form. Okay, so this is the example. Let's check another one. So when we check this part inside the parenthesis, we actually have, you can treat it as the -x times y3. Or you can also treat it as -1 times x times y to the third. So you will always get the same answer if you treat it as the product of -x times y to the third. You will think the first base is -x. Now you should but make sure you understand this is still 1 for the x. And next term, you will treat y to the third. Then the outside will be 5. After that, you understand the negative sign is still here because it's the odd number exponent. So we will, if we want to write it into the multiplication form, we will get the odd number negative sign, right? So we will know the final answer is still the negative. So negative. This is one way to do this question. Just like I said, you can do it like the second way. You can treat it like -1 times x times y. Then the outside is 5th. Then you can put the first -1 to the 5th. Then the second term x to the 5th. Then the last term y to the third to the 5th. Now we know this one still because we have 5 negative sign. So that means it's odd number. Odd number, -1 times -1, 5 negative sign. Put them together, we will get the product is still the -1. And remember, this is x to the first. So the exponent for x is just 1. So 1 times 5, we will get 5. And for y term, 3 times 5, we will get 15. Okay, so if you want, you can just keep the answer like that, or you can like this. Okay, so this is called the power of a product rule. Let's check the power of a quotient rule. So let's see, if A over C, of course here C is not equal to 0, then we will write it like A to the n, C to the n. It's still the quotient. A quotient inside the parenthesis after we put it to the parenthesis to the exponent, we will still get the quotient. Okay, let's see the example. So first of all, we know we could treat the whole part as the quotient, right? We could treat the part as quotient. Now we could use the quotient rule. Then we think the top will be the whole part. The top, treated top to be the whole part. Then we check the bottom to be the whole part. So by using the quotient rule, right? Now we go to check the top part. Now we could use the product rule, right? We will think the first term in the parenthesis is 2. Then we use the product rule. We know 2 to the 4th times x 4 times 4, because here we know it's 2 to the 1. And we do the same thing. For the bottom part, we know 3 is just 3 to the 1. So we will get 3 to the 4th, y 5 times 4. So after that, we can evaluate. we'll get 16 for the first part, and x to the 16. And for the bottom, we will have 81 y to the 20. Okay, so of course we know y cannot be 0. Okay, so the quotient rule, power of the quotient rule and the power of the product rule are very similar. If it's the quotient inside the parenthesis, then after we put the exponent, it will be still the quotient form, right? It's a quotient and it's still the quotient. If it's the product inside the parenthesis, a times b, then after we put the parenthesis to it, it's still the form of the product. So let's check next. Next one will be use the quotient rule and define the zero exponent. Let's talk about the zero exponent. Because we have this rule. This called quotient rule. Last topic we talked about the power of a product rule and the power of a quotient rule. Right, this time it's about the quotient rule. We need to do the division, right? A to the m divided by a to the n, and we realize these two have the same base. Then we just keep the same base, a, and find the difference, m minus n. So again, the top exponent minus the bottom exponent. Okay, so let's check some example. Let's check example. For example, we have 2x 5y. So let's check it one by one. The first term here is 2 on the top, right? But the bottom, we do not have any number, so you can treat it as 1. So the first term, number divided by number, we have 2 divided by 1, we have 2. Then the second part is the x to the 5 divided by the x to the 1 actually here. So we will have x, keep the x, common base here is the x to the 5 minus 1. Then for the y part, we have keep the y. Then we find the difference between 2 minus 1, because here the y is still have the exponent 1. So after that, we rewrite our answer like this. You can write it like this, or you can just write it like this. Okay, so this is called the quotient rule. And we have another property is if a is not equal to 0, then a to the 0, we will always get a value 1. Okay, if a non-zero number raised to the 0 power, then it is always equal to 1. Okay. So the last objective is you should pick which rule to use. You should pick which rule to use. Okay, so for example, if we have this one, so obviously it's a multiplication, right? and we realize they have the same base. So we should keep the same base. Remember, if we keep the same base, we just find the sum of two exponents. So this is called multiplication rule or the product rule. This is called the product rule. So first, it's a multiplication, right? And with the same base. Now we could keep the base. Then we only need to add up to find the sum of two exponents. For example, we have this term. So first, we could use we can write it into this way. The power of the quotient rule, right? So first, in the parentheses, we have the quotient. So we can use the power of quotient rule to write it into this one. Remember, in the parentheses, it's a quotient. Then after we put the exponent to it, then it's still a quotient. So after that, we will have this one. For example, this time we have this one. So first, we check the parentheses. Inside the parentheses, we have two terms, right? The first term, we can think it's the product. Inside the parentheses, it's a product. So we could use the power of the product rule to put it like this way. Now, we check this part. We realize inside we have an exponent and outside the parentheses we have another. This is the power rule. So we only need to find the product of these two. So that will be. So by this time we know we have several rules to operate the exponential expressions. So we have the product rule. If we do the multiplication and these numbers have the same base, then we could use the multiplication rule, the product rule, sorry. And we also have the power rule. Remember, inside the parentheses we have the power, outside we have another one. Then we write down the base, then find the product of two exponents. We also have the power of product rule. So inside the parentheses, if it's a power, then you put the exponent to it, you will still have the product. And we also have the power of quotient rule. If inside the parentheses you have a quotient, then after you put the power to them, it's still the quotient. The last one is called the quotient rule. So if you do the division and these numbers have the same base, you can keep the same base, the common base. Then you should find the sum. You should find the difference of the exponents. Okay, but make sure it's the top one minus the bottom one. M minus N should be. Okay, that's all for the 5.1.